Okay, so let's start this final review. It may take a couple videos, we'll see, but I'll get through as much as I can quickly. So on number 14, when you have a limit like this, the first thing I would do is try to plug that in and see what happens. So if I plug it into this top part, I get e to the 0 minus 0 minus 1. Anything to the 0 power is really 1. So this is 1 minus 0 minus 1, which is 0. On the bottom, I'm going to do cosine of 2 times 0 minus 1. So that's really the cosine of 0, which is 1. This right here is 1. Minus 1 is 0 again. So you can check a calculator for that, or you can check your unit circle, but you end up with 0 over 0, which is an indeterminate form. Anytime you get an indeterminate form and you're talking about a limit, I would do L'Hopital's rule. So first thing I would do is show that you got an indeterminate form, because that's kind of the rule. Like, you have to get it into an indeterminate form in order to do L'Hopital's rule. So once that's true, then you can do L'Hopital's rule, which is where you leave the limit the same, leave that the same, but then do the derivative of the top and the derivative of the bottom separately. So I'm just going to go through each of these separately. The derivative of e to the x is e to the x, minus the derivative of x is 1, and then minus the derivative of 1 is 0, so I would just leave that part alone. And then on the bottom, I've got kind of a chain rule there, so I'm going to do both. So I've got the derivative of cosine is negative sine, so I have negative sine of 2x times all of that, times the derivative of that inside part, which would be 2. And then minus the derivative of 1 is 0, so I can just leave that off. Okay, so then let's simplify that just a tiny bit. So this is really the limit as x approaches 0 of e to the x minus 1 over negative 2 sine 2x. You could kind of simplify it like that. And then plug 0 in again. So now I'm going to plug 0 in here. E to the 0 minus 1, which is 1 minus 1, which is 0. And then this one I've got negative 2 times sine of 2 times 0, or just 0. Sine of 0 is 0. So then I end up with negative 2 times 0, which again is 0. So I still have an indeterminate form. Okay, which means I need to do L'Hopital's rule again. If you end up with another indeterminate form, just do it again. So again, this is still going to be the limit as x approaches 0. But this time I'm doing the derivative of this. So I think I'm going to look at this one just because it was simplified a little bit. So let's start with the top. The derivative of e to the x is e to the x. The derivative of this minus 1 would be 0, so that goes away. All over the derivative of this right here. So let's start with this. The negative 2 I'm just going to leave alone, times the derivative of sine is cosine, still 2x, but I still have to take that times the derivative of this inside piece, so times another 2. Don't forget that next chain rule again. So this is really the limit as x approaches 0 of e to the x over negative 4 cosine 2x. Okay, so now I can plug in my 0, and it's not going to be just 0. So I can already tell that this is going to be something other than 0 up here, because e to the 0 is 1. And then I've got negative 4 times cosine of 2 times 0, or just 0. So this is going to be 1 over cosine of 0 is 1, so that'd be negative 4. So I end up with negative 1/4 as my answer. So just be careful with your chain rule. I definitely wrote these problems the way that I did for a reason, so make sure you're checking this chain rule over and over and over again. All right, this one, when I have a limit as x approaches infinity, basically it's asking me, what is happening as this is getting bigger and bigger and bigger, as x is getting closer and closer to infinity, right? If this were negative infinity, it'd be the opposite direction. What's happening is it's getting closer and closer to negative infinity. So what I really want to know is as x is getting bigger and bigger, what is happening to f of x? So let's say I look at, like, in this case, it's positive infinity. So I'm going to go 10, and then maybe 100, and then maybe 1,000, until I can, like, really see what's happening, okay? So if I did this on a calculator, you're just plugging these values into this function for x, okay? If this were a y, I would be plugging y values in and seeing what x equals. So I would just do the opposite. So I could, on this right here, plug in 10, 100, 1,000 for y if that were the case, and then just see what was happening here. Same thing. So if I plug those in, I got this. I got 0.9997, and it kind of like kept going. This one I got 0.999, and it kept going. And this one I got 1. So it's definitely getting closer and closer to 1. And this, I think my calculator probably just rounded it for me because it was just so close. So my answer on that one is 1. So you're just checking to see what is it getting closer and closer and closer to every time. Okay. Number 15. This is the one that kind of goes on and on forever. So let's start with one thing at a time. These are all kind of considered separate questions in this question, so just make sure that you do each completely. So the first thing they want to know is, what are the intercepts? Well, the intercepts are with the original function, when is y 0 and when is x 0? Because on the axis, if I'm looking at an axis, if I'm looking at an x-intercept, that means my y value is 0. If I'm looking at a y-intercept, that means my x value is a 0. So I'm just looking to see where are x and y 0. So I'm going to start with, let's plug 0 in for y. Oh, that's a 4. So I'm going to solve that one. And then the other thing I'm going to solve is if I plug 0 in for x. Like that. So my first one, if I solve this out, let's say I multiply this side by this stuff, I'm still going to get 0 over here. So it's really 0 equals x squared plus 4. So if I minus 4, negative 4 equals x squared. So I'm not going to get a real number here. If I try to square root a negative, that would be an imaginary number. So I'm just going to say that there are no x-intercepts, because when I'm trying to solve for x here, there isn't one. It is possible, though, that I could have gotten an imaginary number. So I could have said, really, I probably should say no real number x-intercepts, but I think no x-intercept is acceptable, so it's not a huge deal. This one, when I solve, I'm going to actually change this to y, just so that I remember I'm talking about a y-intercept here. That's going to give me 4 over 4. So y equals 1 is my intercept. Now I want you to be careful. They really want you to list it as a point. So they want me to give coordinates of any point. Okay, so an intercept is a point. So that means I really need to list this as 0, 1, meaning my y value is the 1. Okay, so if you do get intercepts, if I got an x-intercept, let's say I got the x-intercept was 2, then that would be 2, 0. Make sure you put those. All right, what are the vertical asymptotes? Vertical asymptotes happen in rational functions where the denominator is 0. So I just needed to figure out where would that denominator equal 0. So I'm just going to solve that. That really is 4 equals x squared. So that means I've got plus or minus 2. So I could list it like this, or I could list them separately. This is not a point. A vertical asymptote is a line. So when I have asymptotes, they look like this. Like I've got this line going through here, right? So these I do not have to list as a point. I can list it like this, or I could have said x equals 2 and x equals negative 2 as my two equations. Part C. What are the horizontal asymptotes? This is the one where you have to kind of look and see what the coefficients are on your original function. So when I look at this original function up here, f of x equals x squared plus 4 over 4 minus x squared. So I would look what's in front of, so if I look at this x squared, that's my highest exponent, and this is my highest exponent on this one. I'm looking for the numbers in front of those. If they're the same, I'm looking for the coefficients. So I need the ratio of the coefficients, okay? And when it's a horizontal asymptote, this one is going to be a y equals something. I think on my answer key I wrote it as x equals. It should be a y equals, because a horizontal asymptote looks like this through here. So that means it's crossing the y-axis. So that should be a y equals whatever it is. In this case, I've got a 1 on top, and then I've got a -1 on bottom. Be careful with that sign. So this one is a 1 over -1, or just -1. So y equals -1 is my horizontal asymptote. Okay. Then, on what intervals is the function increasing and then decreasing in this one? What I love about this question is they already gave you the derivative up here. So I'm doing, to find this information, I need to do a first derivative test, but they already gave me the first derivative. So I'm going to write it down right here just so that I have it in front of me. 16x over x squared minus 4 squared, like that. All right, so I'm going to start out by saying, when is that derivative 0 and when is it undefined? Those are my two important things happening. So when is it 0? So 16x over x squared minus 4 squared, when does that equal 0? Well, if I just multiply this over here, that really is when 16x equals 0, so that's when x equals 0. When is it undefined? It's undefined when your denominator equals 0. So in this case, it's really when x squared minus 4 squared equals 0. So when is that going to happen? That's when x squared minus 4 equals 0, which is when x squared equals 4, which is when x is plus or minus 2. All right, so those are those like critical points that I'm looking for. So when I set up my first derivative test, I'm going to have to go from -infinity up to -2, and then from -2 up to 0, and then from 0 up to 2, and then from 2 up to infinity. Okay, so this is what I'm looking at. When I make my table, I'm looking for some test points in each of those intervals, and I'm looking for whether or not it's increasing or decreasing within those points. So this one I'm going to say, let's look at -3, -1, 1, and 3. Those seem logical to me. And I'm plugging those in to the derivative. So I'm taking this and plugging them in right here. What I usually do, so I'm just going to like write out this first one. So if I do f prime at -3, I'm looking to see, is it positive or negative? I don't care what the number is. I just want to know if it's positive or negative. So when I plug -3 in right here, this top is definitely going to be negative. The bottom, I've got a -3 squared, so that's a +9, and 9 minus 4 is a positive number, and then I'm going to square it. No matter what, if I'm going to square this, it's going to end up positive in the bottom, so that's kind of an easy way to find these. If I end up with a negative on top, it's going to be negative. If I end up with a positive on top, it's going to be positive. So that should be a quick shortcut on this one. So this one came out negative, which means it's decreasing on that interval. This one came out negative also, so it's decreasing. This one came out positive, this one came out positive, so those are increasing intervals. So they want to know, on what intervals is the function increasing? It's not okay just to show me this table. You have to say that it is increasing on these intervals. So from 0 up to 2 and from 2 up to infinity. Please do not list it as just 1, 0 up to infinity if they're side by side like this, because at 2 it's not actually increasing, right? That's where it's like flattening out. It has a slope of 0. So don't list it as that. You need to list it as 2 separate intervals. Okay, so then when is it decreasing? Well, I already know that answer. It's decreasing from negative infinity up to -2, and from -2 up to 0. Okay, so hopefully those are easy. I like that they gave you the derivative. That's going to be very helpful on that problem. On the next page, they did this on the exam as well. They went ahead and gave you the 3 functions again, so that's really nice. They wanted to know what points are your maximums and your minimums. So I want you to think about where is it increasing and decreasing and what's happening at those points. So let's go back over here. Let's see, it was decreasing and then it was increasing. So it looks like it was going downhill and then back uphill right here. So this looks like a pretty obvious minimum right here. So I think I can go here and say, well, my minimum is going to happen at x equals 0, because that's where that value was, at 0. The maximum I'm going to have a harder time finding because I'm not seeing any. So they want a local maximum. That means, so if it's decreasing and then it's increasing, I don't necessarily have to try to find this, like when is it the absolute highest it is, because that would be really difficult when my endpoint is negative infinity. Same thing here, it's going to go up, 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 all the way to infinity. It's going to be really hard to find what that's going to be. So I don't have to give them a maximum. In this case, I would literally just say no maximum. But if it went from increasing and then decreasing again, then that would be a maximum point. So just watch for that. Make sure you can find those if they're in there somewhere. This one, remember with a point, I have to give an x and a y value. So I need to find out at x equals 0, what is happening. So what is f of 0? Okay, so that would be 0 squared plus 4 over 4 minus 0 squared, which I already found earlier was 1. So this point, this minimum point, is at 0, because that's my x value, and then 1 is my y value. No maximum in this case. All right, concave up, concave down. Now we're talking second derivative test. So now I need to figure out when is my second derivative, which is this one right here. I'm going to write it down over here. F double prime of x equals negative 16 all over. Okay, I need to figure out when is this 0 and when is it undefined again. So when is it 0? That's where all of this, 3x squared plus 4 all over x squared minus 4 cubed, when does that equal 0? Well, it's really when the numerator equals 0. So when, because if I multiply by this stuff, it's still just 0. If I divide by negative 16, I'm still going to get 0. So I don't need to like distribute this. I can just divide that out and it goes away. So I get that x squared is going to be negative 4 over 3. So if I move that 4 over and then I divide by 3, I get this, which again, that's a negative value. So I'm just not going to worry about that one at all. Unless it's an imaginary number, which again, I'm not concerned about that. So then the next situation is when is it undefined? Well, that's where this denominator equals 0. So where x squared minus 4 cubed equals 0. Well, if I cube root both sides, that's where x squared minus 4 equals 0. So that's where x squared equals 4, or x equals plus or minus 2. So this time when I'm doing my table, I have less things to worry about because on the last one I had 0 as another one. This one I only have plus or minus 2. So I'm really checking from, not negative 2, from negative infinity up to negative 2. And then from negative 2 up to positive 2, so I'm skipping that 0 one, and then from 2 up to infinity. All right, so I'm gonna check negative 3 and 0 and 3 here and see what happens. Again, I'm plugging this into the second derivative up here, so I wanna know what is f double prime of negative 3. And again, I'm probably just gonna like say, I've got this negative out front, and then I have this fraction. What's happening on the top and bottom of that fraction? Well, if I plug in a -3 and I square it right here, I'm going to get a positive value. If I plug in -3 down here, I'm going to get 9 minus 4, which is positive, and then I'm going to cube that. Be careful with this down here, because when you cube it, it could be negative. In this case, it ends up positive down there, but there was a negative out front. So overall, it's a negative. So this one is a negative, which means it is concave down. The other two, this one ended up positive, so concave up, and this one ended up negative, so concave down. So they want to know, when is it concave up? So it's concave up on the interval from -2 up to 2. When is it concave down? It is concave down on 2 intervals, -infinity up to -2, and 2 up to infinity. All right, and then what are the inflection points? So I want you to be really careful with these. So usually I would say to you, it's where it changes concavity. So I would check for that first. But then we also need to think about what's happening at those points. So when is it changing concavity? It's changing concavity here, where it's going from concave down to concave up at -2. So that's happening at -2. It's also happening at +2. It's going from concave up to concave down. So that's happening at 2 also. So it's changing concavity at -2 and +2. But we need to be careful with what's happening with our increasing and decreasing. On this one, at -2, it's decreasing, and then it's decreasing again. So it didn't change directions, I guess I should say right there. It did change concavity, but it didn't change from increasing to decreasing or decreasing to increasing. So it, I guess I could say it like this, but it continuously decreased or increased at those points. So I'm just trying to give you an explanation as to why my answer is going to be the way that it is. So here's my explanation. So there are no points of inflection then because of this. If it changed concavity and it changed from increasing to decreasing or decreasing to increasing, then you would have a point of inflection at that point. So then again, you would have to do what we did back here when we were looking at our minimum and our maximum. I would have to find what that y value was as well and list it as an actual point. Okay, so on this one there were none. All right, number 16. 16 says find all the critical numbers of each function. That first function looks really terrible. I'm going to rewrite that. I'm going to say that this is really the same thing as x squared minus 6x to the 1/5. So remember, when it's a fifth root, that's the denominator on your exponent. So that's a 1/5 right there. So to find critical numbers, I need to do a first derivative. So f prime of x equals, don't forget your chain rule. So this is 1/5, leave this stuff alone, and then make this a -1, so -4/5 times the derivative of the inside. The derivative of x squared is 2x. The derivative of a 6x would be a 6. And then let's see, I'm going to rewrite this because when I find critical numbers, I'm thinking, when is it 0 and when is it undefined? So it'd be really nice if this should be in the bottom of a fraction, I should write it in that way. So I'm going to put all of this on the bottom, and then this 5 is also on the bottom of a fraction. On the top, I've got a 1 and a 2x minus 6. So I'm just going to write it as 2x minus 6 because times 1 isn't going to change it. On the bottom, I have a 5, and then I think I'll leave this with a fraction exponent. I think that's okay. I don't think it's going to hurt me in the long run. So I'm just going to leave this as 4/5. It's just positive now. So then I need to figure out, when is that 0 and when is it undefined? Undefined with an F. Okay. The undefined situation is really easy. It's basically just when is this right here 0, because it's when the denominator is 0. So when is x squared minus 6x 0? Well, I would factor this and then set each of them equal to 0. So that's when x equals 0 and when x equals 6. So these are definitely critical numbers. Remember, it's critical numbers, not critical points. So I don't have to find the other part. I don't have to find the y value. The other scenario is when is it 0? Well, it's going to be 0 if I set this whole thing equal to 0 and I multiply by this side, that's just going to disappear because that's 0. So I really just want to know when is the numerator 0? So that's when 2x equals 6 or when x equals 3. So that is also a critical number. So I've got 0, 3, and 6. You can leave them just like this. You don't have to list them out super formally or anything. All right, the other situation here is, let's see, find a critical number here. So let's do the derivative first, which is going to be a little ugly because of that, but it's not terrible. And then again, I need to figure out when is it 0 and when is it undefined. So let's start with the derivative on this one. This right here, don't forget that that's a product rule. So the derivative of, I'm going to leave this one alone, so I'm going to leave that as x times the derivative of natural log of x, which is 1 over x, plus, now do the opposite, the derivative of x is 1, and the natural log of x stays the same. So that's my product rule. Plus, I have this x right here. The derivative of x is 1. So I'm going to simplify that a little bit because this cancels. And x times a 1 over x is really just 1. So I have a 1 plus, this is just a natural log of x, plus another 1. So this is really 2 plus natural log of x. So that turned out actually very nicely. So now I need to know when is that going to be 0 and when is it going to be undefined. There's not really a case where it's going to be undefined because I don't have a rational function on this one. So I don't really have to worry about that here, but I do have to worry about this. When does 2 plus natural log of x equal 0? And this is where most people have a hard time coming up with an answer. So let's solve this out. Let's get natural log of x by itself here equals -2. Then let's rewrite what x is. I have to solve for x. X in this case, if I raise both of these e to the something power, I end up with e to the -2. Raising this to an e, or not raising it to an e, I don't know how I'm saying that really wrong. To get rid of a natural log, you do e to the something, right? So this rule is that e to the -2 equals my x value in this case. So e to the -2, you could leave it like this. I'm a little more comfortable with saying that that is really 1 over e squared. That looks a little bit nicer to me, but it's okay if you left it like this. I don't think they're gonna get too upset. I'm grading it, so I would count that as what I'm saying. Okay, let's see, we've got 17, 18, 19, I think I'm just gonna keep going. So number 17, the area of the region bounded by these two graphs, they want me to find that. I would kind of map these out in a graph. So I would graph those two functions. So I would maybe do like some tables, like XY tables for these. This one is actually pretty simple, but maybe start with saying, well, where are these two things equal to one another, right? So if I set them equal to each other, I don't know if I posted my answer key or not, but I didn't even finish this problem on the answer key. So if I posted it, you may want to be questioning that right now. All right, so I'm going to set these two functions equal to each other so I can figure out where they cross. And if I do that, if I solve all of this out, I'll go ahead and do it because it does get kind of messy. So if I minus 9, I get -3 over here. And if I square this out, I have a negative, but I have an x squared over 4. So I'm going to multiply everything by -4 here. So that would be positive 12 and then plus 4x. And then I'm going to move everything over and factor. So x squared minus 4x minus 12 equals 0. Factor this out. I'm going to get, sorry, I'm totally off the page here. I'm going to get a 6 times a 2. If the 6 is negative, that gives me negative 4 there. So that means x equals 6 and x equals negative 2. So what that tells me is my functions are crossing at positive 6, and at negative 2. So what I really want to know is what's happening at negative 2, what's happening at positive 6 for each of these, and then what's happening kind of in between. So if I could pick a couple of points there in between, that would be nice. All right, so at negative 2, if you plug that in, you should end up with 8. And at 6, you should end up with 0 on both of these, 8 and 0. So at negative 2, I'm up here at 8, and at 6, I'm at 0. So that's where these functions are crossing each other. So what's happening in between? Let's just plug in 0 and see what happens, and then maybe like one other value, maybe 2. Just plug in a couple values in between. So at 0 on this one, I got 9, and at 2, I got 8. So it looks like it's kind of going up and then back down right there. And then at 0 on this one, I got 6, and at 2, I got 4. You could plug in more values in between there also if you want, if it bothers you that I don't have all of them. So at 0 on this one, I'm at 9, which was a little bit higher than that one. And then at 2, I'm back down to 8. So it looks like it's going kind of like this. And then on this one, I'm at, let's see, here, and then I'm at 6, which was down a little bit. And then at 2, I'm at 4, which was down a little bit further. Okay, so it looks like this one's going like this. It was a linear function. Wish I had sketched it a little bit better, but you get the idea. Okay, so then that tells me when I'm finding area, remember when you're finding area, you need to know which one is the top, which one is the bottom. So I need to do an integral here, and I'm going from negative 2 up to 6, and I'm putting my top function first, top minus bottom. So my top function was this one, 9 minus x over 2 squared, minus my bottom, which was 6 minus x, and all of that dx. Okay, so now I need to simplify, integrate, and then plug in my numbers. So this is going to be a lot. Okay, so 9 minus, I'm going to go ahead and simplify that to an x squared over 4, minus 6 plus x, so be careful with that. You could rewrite this as 1/4 x squared, if that helps you a little bit. And then all of that dx. I probably will go ahead and simplify that because it would be nice if the 9 and the 6 were together as just a 3. And then I think I will make this a 1/4 x squared so that when I integrate it, it's a little bit easier. All right, so now let's go over here. Let's actually integrate this. So the integral of 3 is 3x. The integral of this is going to be, that's going to make that an x to the third. And then I need to divide by that new exponent. So that's going to make that a 1/12. And then plus, I'm going to have an x squared on this one, divide by the new exponent. And then I'm going from negative 2 up to 6. Okay, so that means I've got a 3 times a 6 minus a 1/12 times a 6 cubed plus a 1/2 times a 6 squared, all of that minus a 3 times a negative 2 minus a 1/12 times a negative 2 cubed plus a 1/2 times a negative 2 squared. Sorry that you can't see all that because it's running off the page. All right, so now I'm going to do some calculations. So this is really 18, 6 cubed, 216 divided by 12 would be another 18. plus 6 squared is 36, divided by 2 is going to give me another 18. So these two cancel, I just end up with 18 there. Minus, this would give me a negative 6. A negative 2 cubed, be careful with your negatives. Make sure you type that in correctly and get negative 8 for that piece. Where am I at? Right here. And then I'm going to divide that by 12. So when I divide it by 12, I could write it like this, or I could write it as negative 2/3. But remember, this was a minus right here. So that'd really be plus 2/3. Make sure I'm not messing up my signs here. And then plus a 2 squared is 4, divided by 2 is 2. So I really have 18 minus, let's just type this in, a negative 6 plus a 2/3 plus a 2. Gives me negative 10/3. So that's really 18 plus 10/3, which is 64/3. So that's how I would write this one, 64/3. Technically, this is square units also, so you might want to put that on there. All right, make sure you talk to me if I made a mistake somewhere. I did that very quickly and didn't check it with an answer key, so make sure you check me on that one. Number 18, find all values of C satisfying the conclusion of the mean value theorem. So mean value theorem, I feel like we need to kind of revisit this. Mean value theorem says that f prime of C, or the derivative, is really like f of B minus f of A all over B minus A, which is really just a slope, right? This is like your y value minus the other y value over x minus x. Okay, so what I need to do is find the derivative of this. So f prime of x equals, that'd be 3x squared plus 2. And then I need to figure out what is happening at both of these points, because I need to plug that in, f of B and f of A. So what's happening at f prime of 3? I'm going to put that one first because it's always the second one first. So that's 3 times 3 squared, which is really 3 cubed. Okay, hold on. I'm doing the derivative. I'm sorry. Let's go back. That is incorrect. I need to be finding f of B and f of A, not the derivative of those. So the function at those values. So let's go back up here. I'm just trying to plug values in right here, and I was plugging into the wrong thing. So this should really be 3 cubed plus 2 times 3. And then this should be negative 1 cubed plus 2 times negative 1. So that would be 27 plus 6 would be 33. And then this would be negative 1 minus 2, so that's negative 3. So what I need to figure out here is, so f prime of C, this is 33 minus a negative 3 all over 3 minus a negative 1. So that's me just plugging these values in and finding this derivative. If I do that, I end up with 36 over 4, or just 9, right? So they're telling me that when I did my derivative over here, this derivative, 3x squared plus 2, that has to equal 9 at some point, according to the mean value theorem. So then they want to know, well, where is that? Where does that happen? So where is f of C? Where is that happening? So if this were a C value, what would that be? Okay, so then that would be 3x squared equals 7 if I solve it. So x squared equals 7/3. That doesn't come out very pretty, but that's okay. So x equals plus or minus the square root of 7/3. That's the C value where that would happen. So plus or minus square root of 7/3. Okay, number 19. 19 says integrate or find the general antiderivative. Anytime I see that, that should be kind of a reminder that I need to put a plus C on it because it's a general antiderivative. So the first thing I'm going to do on this one is divide this out. Like there's so many x's in this problem. If I divided each of those by x squared, it's going to make it look so much simpler. So x cubed divided by x squared is just x. And then minus a 4x squared divided by x squared is just a 4. Plus this 7, I'm just going to kind of leave alone. But this x divided by x squared, I'm going to write that as 1 over x. Now, hopefully you'll remember why I'm writing it like that, because that's an easy integral to take. Okay, so this one, I would not rewrite that as x to the negative 1, because you have to remember that like special case for this one. But let's start here. If I take the integral of x, that gives me a 1/2 x squared. The integral of 4 is 4x. And then plus, I'm going to leave the 7 alone. The integral of 1 over x is the natural log of x. Make sure you put your absolute value bars. And then don't forget your plus c on the end. Okay, so I would just stop there. It just wanted the general antiderivative, so I don't really have to do anything else there, and I can't simplify anything there, so I'm good. All right, B is kind of the same way, except this is kind of crazy. So typically when you're doing an integral, if there's a chain rule, if you can see that there's a chain rule, you really either need to just multiply all of that out, which to the 12th power is going to take forever, or use u substitution. So you could say that your u value is x squared minus 4, which would then make du 2x dx, which is really nice because 2x and dx can just be replaced with du. Okay, so that means I really have an integral of u to the 12th du, because this and this is just du, and this right here is my u to the 12th. Okay, so then I can actually integrate it. That's going to become u to the 13th, and then a 1 over 13 at the front, plus a c, don't forget your plus c, and then I'm going to plug my u value back in. So this is really 1/13 times x squared minus 4 to the 13th plus c. All right, and then number 20, use the definition which they gave you, which is really nice, that limit definition of a derivative, to find this value. Okay, so we struggled with this back when we did it, so I just want to remind you again. So this is going to be my f of x with a plus h. So instead of putting x, I'm going to put x plus h. Anywhere I see an x, I'm going to put an x plus h. So this is really the limit as, not x, as h approaches 0 of my first part right here. This piece is my function with x plus h plugged in. So this is the square root of x plus h plus 1. That's this function with x plus h plugged in. Minus, now I want just f of x. That is my function as is. So the square root of x plus 1 all over h. Okay, so now the problem is I need to make this look much nicer. This is not pretty enough, mainly because if I go to plug 0 in for h, I'm going to have an undefined situation, which is not okay. So I have to fix this before I can plug in my 0 value. So what I'm going to do, and what you should be thinking here, is this is like a difference of, and I've got these weird square roots. I need to try to rationalize that numerator. So this piece right here, I'm going to multiply it by kind of the opposites, right? So I'm going to take this. Actually, let's simplify something first. I can make this look a little bit better before I do that, because I have a 1 right here and a minus 1 right here. So let me rewrite this for a second. This is really the square root of x plus h plus 1 minus the square root of x minus 1 all over h, which really means I have this. this cancels this. So I have the square root of x plus h minus the square root of x all over h. Now when I rationalize this numerator, it's going to be a lot nicer. So I'm going to take this times the square root of x plus h plus the square root of x. Same thing with the denominator, x plus h plus the square root of x. That's really messy, sorry. Okay, so that's going to give me, if I multiply this out, I'm going to have an x plus h plus that minus that same thing. So the middle two terms are going to cancel. And then this is going to be minus an x. All over h times, and I am not going to multiply this through. I'm just going to leave it. X plus h plus the square root of x. Okay, so here's what happens on this one. This x and this x cancel. So that gives me h over h times the square root of x plus h plus the square root of x. Well, the good thing about this is these h's are also going to cancel and make it 1 over that stuff. So this is really the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. Now I can plug in my 0. So that's going to give me 1 over the square root of x plus 0 plus the square root of x. Well, that's really just 1 over the square root of x plus the square root of x, or 1 over 2 square roots of x. So I would stop there. So when you first start this problem, I would plug in those values like you're supposed to, and then simplify it first before you try to rationalize the numerator. I started to rationalize it up here, and that would have been really hard to do with those ones in there. It would, well, not really hard, but it would have made it messier. So once I cleaned it up a little bit, then it was easier to do. Okay.